Hello guys, welcome back to a new video. So let me just share the complete view. So today we are going to solve this permutation in string problem. If you are new to this channel, we have already solved these much of problem. You can see the green tick here, and you can follow along with me. You can solve all these problems. If you haven't watched those problems, you can open my channel and you can find those videos over there. So you can find all these video. I have also created a playlist, so you can follow that playlist. Okay. So I have already opened this problem here. Okay, let me see if it is visible. So given two string s1 and s2, return true if s1 contains a permutation of s1 or false otherwise. Okay, in other words, return true if s1 permutation is in substring. Okay, so this is s1 ab and this is blah 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 s2. So we have to check if any permutation of or this s1 is present here or not. So if we rearrange this in any order, it is present here or not. So you can clearly see BA, which is the rearrangement of this S1, it is already present here. Okay, so that's what we have to check, if it is present or not. We have to just check if any of the permutation is present here or not. So here it is AB, and you can see B, and there is no corresponding letter A here. So and also for A there is no corresponding letter B here, so there is no permutation AB present here in this word. So this is pretty simple. Now there will be approach will be like many approaches. So what we can do is, so we have a window of size this s1, so the length of this will be the window. So you can see this is a sliding window problem. So the window will be of length of s1. So we will circulate starting from the 0th character in this way. We will have the window size of 2. We will check in this window, we will sort this and we will compare this with the given string. We will sort both these strings and we will compare if they are equal or not. So that's the one approach. So that will take so if we take this as sorting as if this the size of this, let's say m, so that will be n log m, and every time we will do this here in this, so it will be n log m here for all these length of this word. So so that will be n into log m log n. So that will be quite heavy for 10 to the power 4. So what we can do is we can optimize that. So we will see, let's see how we can optimize that. So let me take this example. Let me try to tell you the approach. So if you can see, we have s1 as AB and s2 as this. So what we can do is we can have two vectors. Okay, that will store the frequency. So this is English alphabet, so we have clearly English alphabet. You can see all lowercase English alphabet. What we can do, we have a vector of, we can have two vectors of size 26, let's say v1 and v2. Okay, so 0th index in this, so it will be of size 26. So let me just try to write this. So this will be like dot 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 all the way to 26. Okay, so similarly this will be the same. This will be all starting from this and 26 character. So here the first element here in this vector will represent A, then the second element B, C, and so and so forth till Z. So all these will be from A to Z. So all this will be 26 characters. So 26 characters. Yes. So let me just so v1 will have these characters corresponding to s1. So this will be a one-time process. We will calculate all the frequency of s1. So for S it is A for it is 1 and B rest all will be 0. So rest all will be 0. Okay. And for V2 what we will do is initialize with this length of this S1. So what we will do, we will iterate over this till the length of the S1. So length of S1 is 2, so we will iterate over this and initialize with this. So E, let me just randomly write here. For E it will be 1, and then I it will be 1. So I just randomly write. You just try to focus on what I'm trying to say. So now after calculating this, we will compare both of these. If they are equal, then the word till now or the characters till now having the length of this are equal. So then we can return true. Otherwise, what we can do is, so currently the window is of size length of S1, which is 2, and then we will get circulate or move our window to the next pointer. So the next window will be like this. Previous window was like this, and next window will be like this. So since we move to the next character and removed one character, so we will update the frequency corresponding in this. So E will be decreased again. So this if it is this was D E, then we will decrease it to again 0, and then increase the D. So D, let's say here, and this is C and this is D, let's say. Okay, so we will increase this. So then again we will compare it to, if they are both are equal, then we will return true. So in this way we will circulate our window till the last element, sizing the size of S1, and we will check for every window if it is equal or not. So yeah, let me just write the code, and then we will try to explain it again. So yeah, and also we are running the for loop for, let's say the S1 is maximum, so we are running the for loop. Let's say it is n, so it will be n, and here we are checking these two. Sorry, this is the n. We will run from here to here, so this will be n, and here we have like two. We every time we move to the next element, we will compare these two vectors that of size 26. Always they will be 26, so it will be like n into 26 always. So that's the time complexity. So do we remove the constant value, so it will be n. So that's why we choose this approach. So let me quickly write the code here. So first we will calculate n. M is s1 dot size, as I told you. Then we will calculate n is s2 dot size, and then we'll have a vector of, let's size 26. We'll initialize all the values with 0, and the name of this vector will be freak. Okay, so it's vector of name frequency s1 frequency, and it have 26 values, and all values will have with 0. Similarly, we will have a vector of same size, and the name of will be freak s2 underscore free. So that will also have 26 values, and all initialized with 0. So then first of all, what we will do is we will update our this v1 vector, and this will only updated for one time. So let me quickly update this. So it will be like this: char in C, char C in S1, and S1 underscore frequency of C minus A plus plus. Minus A will give us the index. Okay, this is pretty standard and simple. Then what we will do is we will run our loop, as I told you, till the initial window that will be of start with the 0 and have the size m, and so this we will run in this s2. Although we have taken the size m2, as I told you, it will be always be smaller. So as size of S1 will always be smaller than S2, then only there one exists. Otherwise what we will do is, if m is greater than n, then we will simply return false. So it cannot be a possibility that S1 is greater than and we find a substring inside that. So yeah, so that what we will do is, we will calculate the char here. So char will be like S2 of ith value, and what we will do is, we will increase the frequency here of C minus A. So this is in S2. So this is also a one-time process. So let me remove this here and directly write this as like this. Okay. So S2 of ith character minus A plus plus. So this will pre-populate this for this window. Now we have like initialize this window here. Now we have like rest of these values. For those, what we will do is, we will start our loop I equals to this m, and then I is smaller than n, then I plus plus. I would have like clubbed these for loop to into a one, and then have like write the logic here with the condition, but I just want to show you how it is going to work. So that's why I separated these for loops. So first for loop, it's initializing the window, so it will run for the length of the window, that is m, that is the size of the S1. Yeah, and then it initializes this window. Then we will write a function. So it will check if they are equal or not. So check equal. So it will take, let me write in this way, it will take two vectors, and these two vectors A and requirement is like these two vectors are always be of same size. This v1 and v2 will be always be same size, 26. Okay, so let me write here n equals to a dot size, and it will, what we will do is, it will just return true here, and it will check for I in I equals to 0, I is smaller than n, I plus plus. If the corresponding value ith value at this is not equal to corresponding ith value at b, then it will return false. So as I told you here, it will compare all these corresponding index values. If they are not same, that means there is no permutation of the current window that forms this letter S1, that is here AB. So IE never forms a corresponding permutation AB, because they cannot be, the characters frequency cannot be the same. Okay, so that's why I like compare these frequency A and B. So yeah, let me just pass here the frequency. If so yeah, here we will return true, and sorry, here we will return false. We have to check for the true condition. So yeah, if check what's the name, check equal of like S1 and S1 underscore frequency and S2 underscore frequency, these two vectors are equal, return true. Okay, otherwise it will move the window to the next value. Yeah, and also since the first window is also a valid window, so we have to check for this window as well. So the first window is of length m, and before running the for loop till from the next like this value, we formed a value till now this let me just, yeah, the current window in this for loop we formed this window, and we have to check this window also. Yeah, so that's why we have to check for here also. And then what we have to do is, we have to decrease the frequency and increase the frequency. So the current character is s2 of I here, and first what we will do is we will decrease the last frequency. The current window is this. We have to decrease the frequency of the last value and increase the frequency of this video, so the window will become this. So we are currently at this this position, this character, this one. Okay, so the character C now represent this. So we are extracting from this s2 given string, and then what we will do is we will increase the corresponding count in s2 like this, and we have to decrease the corresponding size in s2 as well. That will be like I minus the length of the window. So, and the character will be s2 of this this character, and also we have to minus this to get the index. So that's we have to decrease. So now here I is, you can see I is 0, 1 and 2. So I is here 2. Okay, 0, 1, 2. Yes, I is 2. So 2, the value here in the 2 will be increased. So this D will be increased in the frequency map here, and now I is 2 and M is 2. So 2 minus 2 is 0. So what is the character at 0? So that is E. So frequency of this E get decreased from this S2 map. So that's the simple logic here. So we will move to this window then, and then in the next video we will do the same. We will add this B frequency to increase this frequency B, and we will decrease the frequency I, depend on the size of the window. Yeah, so that will be the logic for this. Let me try to check it if it works or not. It worked for this case. Let me submit it and see if there is an error or not. Yeah, it's working for all the cases. So as I told you, the time complexity for let's say this for loop is M, and for this is 26. Here we, in this function, we are always will be 26 as we know, and this n, this is running from M to N. Let's at max it will be N, and here this is 26. So this is the maximum time complexity here, N into 26. Rest all are like minimum. So overall time complexity will be N into 26, and 26 is a constant, so we remove this, so the time complexity will be O of N. So yeah, let me write the TC here. It will be O of N, and also space complexity. So space complexity is 26, because we are just storing these 26 values only. So it can be like O over N, because O 26 is a constant. So yeah, that's about this video. If you like the video, please hit like. I am seeing like people are not liking the video, not clicking on the like button, although they like the video. But yeah, and also consider subscribing, and let me tick this, and tomorrow we are going to solve this problem. So till now we have like 16 or 17 problem we have solved. You can check out the channel, and I will see you in the next video.